So we've seen that when a polynomial has 4 terms or 6 terms, we can approach it using factoring by grouping. However, we often see trinomials when we're asked to factor expressions. And the next couple of videos are going to focus on how to factor trinomials, which often factor into 2 binomial pieces. So we're talking about how can we factor expressions that look like this, ax squared plus bx plus c. And in this video, we're going to make it easy and stick with a equals 1. That means there's no other leading coefficient at the beginning of this trinomial. Now remember, I said that factoring is the opposite or reverse of multiplication in a lot of ways. So in order to establish some patterns here as we begin to factor trinomials, let's think about how multiplication works. If I multiply the binomials x minus 5 times x plus 4, my result is x squared, then I have minus 5x plus 4x. So I'll go ahead and combine those in my head. That gives me negative x. Finally, I have minus 5 times 4, minus 20. So the result here is x squared minus x minus 20. As I multiply these binomials, I'll have x squared plus 3x plus 2x, which gives plus 5x, plus 3 times 2, which is 6. Finally, another one, x times x is x squared, minus 1x, minus another 1x, that's negative 2x. Finally, we have negative 1 times negative 1 is positive 1. So here's some trinomials that I created by multiplying 2 binomials together. As we factor, we're starting with expressions like this on this side, and we're moving backwards to find those original binomial factors. So let's think about some patterns here. What do we see as we multiply more and more binomials together and compare them to the final trinomial answer? Well, here's one pattern that we notice. The 2 numbers in the factors showing up here multiply to make c, that's the last number in the trinomial, and they add to make b, that's the middle coefficient in the trinomial. And that's exactly where these came from, right? Remember, to get this value of negative 1x, I combined or added negative 5x plus 4x. So these 2 factors add to make negative 1, and they multiply to make negative 20. That pattern is true across all trinomials as long as a equals 1. So I have 3 times 2 is 6, 3 plus 2 is 5. Negative 1 times negative 1 is 1. Negative 1 plus negative 1 is negative 2. So when we factor, we will use this pattern to work backwards and fill in the missing numbers in our binomial factors. Now that we've observed this pattern, we'll apply it as we work backwards to factor. So factor x squared plus 4x minus 32. Remember that the 2 numbers in the factors multiply to make negative 32, and they add to make positive 4. So this becomes a number puzzle or a number game. Let's find 2 factors of negative 32 that add or sum to positive 4. You can run through some factors of 32 or negative 32 in your head or on a piece of paper. One has to be negative and one has to be positive. That's the only way they will multiply to make negative 32. And we will find that the factors we're looking for are plus 8 and minus 4. These numbers multiply to make negative 32, and they add to make positive 4. So here's our factors: x plus 8, x minus 4. Second, x squared minus 7x minus 18. We're looking for 2 numbers to fill in our factors that multiply to negative 18 and add to negative 7. Again, one is positive and one is negative. That's the only way they multiply to make a negative number. My 2 factors in this case are minus 9 and plus 2. It takes some work to find those sometimes. I don't expect you to get them right away, but keep running through factors of negative 18 until you find a pair that adds to negative 7. X minus 9, x plus 2. Third example, I'm going to rearrange this one first by reordering the terms in descending order. Negative x squared plus x plus 2. And second, by factoring out the negative sign, x squared minus x minus 2. It works best for this factoring approach if the first term is positive. And so I'm factoring out a negative sign. It factored out of every term in order for this first one to be positive inside parentheses. Then I factor it into two binomial pairs. I'm leaving a negative sign on the outside, that's still there. And here we're looking for numbers that multiply to -2 and add to -1. That result is going to be -2 plus 1. So here's our factored form for this example. One more. X squared minus 7x minus 12. Here we're looking for two numbers that multiply to make -12 and add to make -7. Now you might have some trouble finding those two numbers. Numbers that multiply to -12. -12 and +1. Or -1 and +12. Maybe -6 and 2. Or -2 and 6. -3 and 4. Or -4 and 3. We run through all those numbers and we can't find any that sum to -7. So there is no number pair that fits this game, right? Well, there's another option. This trinomial is prime. It can't be factored. Not every trinomial or polynomial is factorable, right? This is an example of a prime trinomial. So we want to watch out for those as well as we factor.